Okay, so this one's a hard one. Let me know if you prefer this style, but for this one, I actually have the solution with me, and I'm just gonna walk through it because I was starting to spend a lot of just waste a lot of time trying to figure it out, and we'll see. We'll go back and forth, but maybe this would be more useful if I actually knew the solution and talked through it rather than tried lots of different ones to see what works. But this is a daily one and it's a hard one. We have strange printer. There is a strange printer with the following two special properties. The printer can only print a sequence of the same character each time. At each turn, the printer can print new characters starting from and ending at any place that will cover the original existing characters. So, for example, it can go like A on the first pass through, and then on the second pass through, go B. We'll cover those three A's with B's. Um, and then finally cover the middle B with an A. So it takes three pass throughs to do that. Um, but yeah, so what you couldn't do is go like A in one pass through. That would take more like, what was it, one, two, three pass throughs. So yeah, so you get what it's saying. And this is a dynamic programming challenge, which I always have trouble with. I don't know why. It's just always been a concept that's kind of eluded me. Even though I think on its surface, it's pretty straight. It's pretty straightforward. You're basically just like caching prior operations so that you don't repeat the same thing over and over, and allows you to build up solutions over time by using the smaller solutions. It's sort of a cousin of recursion in that regard. But what we're going to do is we're going to make a table. So for the record, so this right off the bat, we can see based on the constraints that the length of S can be between 1 and 100. So it's really not expecting us to make it that fast. Otherwise, it would make the constraints much larger. So this is much more of a challenge of getting it to work at all rather than getting it to work fast. And the solution we're going to go for is actually going to be a big O of n to the power of 3. But let's give that a shot. So let's see. First, we have to break down a couple key concepts. Um, what we're going to do is basically make a 2D array. And that array is going to um, calculate the minimum number of moves it takes to complete a substring of the string. So, like if we have A, what we're going to do is we're going to work upwards in little chunks. So we're going to start at substrings of 1, and we say how long does it take to make B? Well, it only takes one move because you can just you can always just take one pass through and say, okay, yeah, it takes one move to print that B. You don't have to encapsulate it with anything, and then so all of them would just be 1. Okay. Now how about 2? Well, for 2, let's see, this would be one move, but then this would be 2 moves because we'd have to do one pass through for A and one pass through for B. And then this would be 2 moves, and then this would be 1 move, and then this would be 1 move. So we're starting to build up like in a 2D array. So the 2D being the first index in that 2D array, imagine a square, is the actually it wouldn't be a square because it would be more like a triangle, like a half triangle, like when you have a multiplication table and you divide it in half on the diagonal because you don't need to do each operation bidirectionally. So it's gonna be it's gonna handle the first index, and then it's gonna handle the first to the second, first to the third, first to the fourth, first to the fifth. So we have one row of the 2D array that's the first index, and the column of it will be the ending index of that substring, and that 2D array is going to be handling the minimum number of moves it makes to create that substring, and that's going to come in handy because of this right here. Um, here's the principle that's going to make this thing work. when we go through the substrings, what we're going to calculate is that or is the first letter of the substring equal to the last letter? Because if that's the case, then the minimum number of moves is the same as the substring with the index minus, well, with the ending index -1. Let me show you. So AB, how long does it take to make AB? It takes 2 moves because you make AA and then you cover the second A with a B. ABA is the same number of moves because you have AAA and then you cover the middle with B. So that's what's going to get us through this. Is that basically if you have two, if two strings, like if you have this right here, this is the same number of moves it takes to make this, and this is the same number of moves to make this. Okay, and that is going to be what gets us through that. We're going to build that up over time and minimizing the number of moves it takes per substring based on that principle that if the first and last character are the same, then it's the same thing as that ending character -1. So let's make this happen. So the first thing we're going to do is we need to initialize that DP table. Now, the DP table, well, so yeah, let's see. So what we're going to do, we're going to hold on to the length of the list. Okay, now we're going to make a DP table, a dynamic programming table. That's going to be a 2D array. All right, so we're going to take 101. And the reason why I chose 101, actually, the solution I have chose infinity, but we know that it's never going to be, each substring is never going to be greater than 101 moves to make because the highest possible string length is 100. So it's never going to take more than n moves to make any string. Even if you have like, you know, like, I don't know, ABB, that's just 2 moves. You know, like I can't think of any. Yeah, it's just not possible. In fact, I think you could even go lower than 101 because I don't think that there's a possible combination. I guess just back and forth, AB, AB, AB. But even then, I think that's going to be half because you can just treat this as like 1, 2, 3, 4, 5, 6, 7. So even though it's, what is that, 14, 13 characters long, it only takes 7 moves. So worst case scenario, it's going to be n over 2 plus 1, or n round up divided by 2, ceiling divide or whatever that is. I don't know. So the solution I have chose did infinity, but I just don't really like working with infinity. I don't like the way it's represented. So I mean, to be honest, that's a very shallow opinion I have. But I don't know. I don't like working with floats. I prefer to work with integers, and you can only do. I don't know. If I can keep it to simple numbers, I want to do that. Now this will not work if if the length of it went to 201, but it's not going to do that. We're going to work within the constraints for some cleaner code. So we're going to do for blank in range n. Okay, so this is going to make a 2D array. So it's going to make this array, it's going to make 101 times n. Okay, so that's 101 times the length of it. All right, for, let's see. Yeah, this is just going to make a square grid of 101s. We only really need half of this grid, but it's going to make rows that each have 101 n times. So if it's 100 and if n is 100, if the length of s is 100, then it's going to be 101 100 times over, and then we're going to do that 100 times over. So there's going to be 100 rows of that. Makes sense? Straightforward, I think. I don't know. Okay, so now what we're going to do is we're going to work our way up. We're going to increase the substring over time. So we have like I was showing earlier, the way we can make the way that we're going to make this work is by processing the how many moves it'll take per substring, and then when we do the bigger substrings, we can just use the results that we got from the previous substrings. Remember, if we have AABA, then that's the same number of moves as ABB. So we're going to build our way up. So we're going to start with those smaller substrings, and then we're going to build them up over time, keeping control of that principle. So we're going to say initialize DP array for starting and ending index of substring. Num is minimum moves. Okay? So at the start it's going to take a minimum number of 101 moves to complete any substring in the array, and we're going to shrink those down over time. All right, and the first thing we're going to do is we're going to handle the substrings of 1, and we can do this as a special case. We don't need to do any math here. A substring of 1 will always take 1 move to complete. All right? So we're going to do, this is our base case. Okay, so we're going to say for I in range n, we're going to just go through all of them. dp I equals 1. Okay, because remember, the DP array, the first index is the starting index, and the second index is the ending index of the substring of the major string. So if we have if it starts and ends at the same thing, then that means it's a substring of 1. And a substring of 1 only takes, I'm going to expand this. And a substring of 1 only takes one move to print. All right? So now we're going to build our way up over time, increasing the substrings that we look at. So we're going to look at all the substrings of 2, and then we're going to look at all the substrings of 3, and so on until the substring is as big as the string itself. And once we get to that point, then we can just access the DP for the total substring, which actually here would be a good question. If you're following along, what will the return value be? All right, because it's going to be something in the DP table. Okay, it's going to be, because the DP table represents all of the values of the different substrings from the first substring to the end substring. I feel like I'm repeating myself. I apologize. DP, so we're going to start at 0, because it starts at, basically what we're going to do is we're going to, as we build up that table of minimum number of moves per substring, we're going to eventually reach the largest possible substring, which is the string itself. And that will be represented by 0 for the first index, all the way to n minus 1 for the last index. Get it? And it's not n because n won't be involved in that. It's a 0 indexed, but length is the total length, so you got to do minus 1. So it's going to be, it's like we're building up that array of substrings. So return substring of first to last index. And I'm going to put i.e. the string itself. Okay, awesome. Okay, next. Now we're going to go, as I mentioned multiple times now, we're going to build our way up in length of substring. So that's going to be our outer loop. So we're going to start with, by going through all the substrings of 2, then 3, then 4, until we get the substring itself. So try to think about what the parameters of this loop would be. It'll be for L for length, or you could just say length. I'll say length to make it clear. In range. And then we're not going to include the 1, because remember, we already went through the substrings of 1 with this right here. So starting at a length of 2 and going through a length of n plus 1, and since, remember, range is exclusive for the upper bound, so we do n plus 1 because we want to go through the length of n, and that's going to be the whole thing. And then once we do that final loop, that's what's going to give us our answer. I'm glad I'm doing this because I feel like I'm making more sense. I am understanding this more as I'm doing it. So so we're going to say I'm going to say for S. Okay? For S to represent starting index of substring. Okay? So for S in range. Okay? And we're going to be, let's see. Now we do have to consider something here, because as the substring builds up over time, we need to make sure that we don't go out of bounds with S. Because if the substring, let's say that the string is 50 and the substring is 25, we only want to go up to 25 for the starting index, because the ending index can only go 25 further. Okay? So, try to see if you can figure this one out. It's going to be n minus length plus 1. Okay? So it's the total length of the thing minus the length of the substring that we're currently looking at plus 1, because it's 0 indexed and we're dealing with length here. Okay? Now we get the ending string. So we'll do E. We're going to say E to represent the ending index of the substring. E equals S plus length minus 1. I'll give you an example of why we do the minus 1. Let's say that we're trying to get if we have A, and we're getting the substring from 1 to 3, being the second to the last character. All right, so S would be 1. E is the length of the substring, which in this case would be 3. So E would be at 1 plus 3, but that's too much. Minus 1 is 3, so that's 3, so it'd be 0 through 3. Okay? Awesome. I feel good about this. Maybe I'll do this more often. Let me know if you like this format. I hope I'm doing well explaining, and if I'm not, then I'm sure I'll get better over time. Regardless, if you're watching, I really appreciate you joining us. And it's actually, it's cool that I'm getting more subscribers doing this. I hope you enjoy. But yeah, so remember that thing that we were talking about earlier when we said that if we have A, B, A, that's the same as A, B? Now we're going to make that happen. This is the key part to this program. The key part to this problem. We're going to say if oh, I'm so sorry, we can't do S. Because S is also the string itself. My apologies. That was a close one. So we'll do start and end. Okay. Okay. Awesome. So now if the start of the substring is the same as the end of the substring, then that means that we can set, this is the key part, okay, this is what it all comes down to. If that's the case, then we can set dp start end to equal dp start end minus 1. Okay? Because we're saying, okay, this is the same as this. Okay? Awesome. That's the key. It takes 2 moves to do that. A, B, A. And it takes 2 moves to do this. A, B. Okay? I'm going to keep that there because I feel like it's important. Okay, awesome. Now, what if it's not equal? We still have to calculate that out. If it's not equal, if those two aren't equal, what we're going to do if they're not equal, what we're going to do is try to find the place that we can split the string that takes the lowest number of moves. Okay? So I'll give you an example. If we have A, B, A, B, we're going to say, what's faster? 1 for A, and then B, A, B. Okay, so, okay, yeah, here we go. I'm going to type this out. Okay, this is, bear with me here, because this is weird. Not equal. Okay, find the split, the lowest sum of moves. Okay? So for example, if we have A, B, A, B, A does not equal B. So, A, B, A, B? Well, we know what A is 1. And we know what BAB is 2. So that means it takes 3 moves. Because it's, remember, BAB is BBB, BAB. Okay, what about AB, AB? Well, that's 2 plus 2 is 4. So it's not that. We don't split it like that. And what about ABA, B? Well, that's the same thing. It's 2 plus 1 equals 3. Okay, so those are the possible things. So that means that ABAB takes 3 moves to make. Because we take the minimum possible value. We're never going to do, the goal here is to find the minimum. Okay, so we're taking the minimum. So we're going to go through all splits of substring. Start does not equal end. Then we're going to go through all splits of substring, and we're going to say for split in range, start, end. All right. I'm going to say DP, start, end. It's sort of a king of the hill situation. I like to call it that. I don't know if it's officially called this. We're going to say DP, start, end, equals DP, what is the minimum between the current champion, which, remember, it starts at infinity, so we don't have to worry about, you know, it not getting updated. Or not infinity, sorry, 101, which it'll always be less than. And DP start end plus, or sorry, DP start to split, and then DP split plus 1 to end. Okay? So that's this right here. For example, if we have start to end, let's say, I don't know, it's ABAB is 5, 6, 7, 8. So the start is 5 and the end is 8. So that means we have 5 to 5 plus split, okay, because split starts at start. So it'd be 5 to 5 plus 6 to the end, which is 8. Okay, and then we increase split because we're iterating through split of start to end. So then we do 5 to 6. Plus 7 to 8. And then finally, we have 5 to 7 plus 8 to 8. Okay? Awesome. I hope you're bearing with me. Let me know if you have any questions in the comments or anything, but I think this is making sense. I also think I'm taking more time than necessary to go through these, but, you know, I'm learning too. And that's it. That's actually it. Once we do this, let's run this to make sure I don't embarrass myself. Yes. Come on, let it work for all of them. Yes. Well, did pretty good on memory. Pretty good on memory. I think it could do better on memory. Or sorry, actually, yeah, sorry, time. Okay. Time-wise, this is really ON3 because we have 1, 2, 3 loops ON1. So, just to reiterate, we're build up the substrings over time. Starting with substrings of 1, we know that each substring of 1 takes only 1 move to write. But if we have if the outer shell of a substring has the same first and last character, then that means that one ending index earlier is the same length to make, because if we have ABA, that's the same as AB. Okay? So starting with all the values being 101 of minimum number of moves it takes to create each substring. We set all of this substrings of 1 equal to 1, and then we work our way up in substring length of 2, all the way up to the length of the entire string being n, and then we do n plus 1 since it's exclusive for upper bounds. Then we iterate through the starting index, making sure to not exceed the bounds by subtracting the length of the substring itself. We then calculate the end of the substring, and we check to see if the first and last string are the same. Well, the first and last character are the same. If they are, then that means that we can set start end to be equal to start end minus 1. That is, just one last time, that is the principle behind ABA is equal to AB. Okay? Then if it's not the same, then we go through all the possible divides that we could divide that substring by and add up those two values. And then we return the dynamic table of the entire thing, of the entire string, which is going to be the first, starting at the first string and ending at the last, starting at the first index and ending at the last index. That is it. Thank you so much for joining me today. Let me know if you have any questions or anything. If you enjoyed, like and subscribe, and let me know how I can do this better for you. If you prefer my more blind approaches where I just go in on its own, or problems more like this where I go in knowing what the solution is. So thank you very much for joining me today. See you later.